Did you know that the rivers near you are inhabited by eels, exceptional for both their history and lifestyle? Amazingly, eels originate from the ocean. All eels are born in the Sargasso Sea, in the middle of the Atlantic Ocean, and their small larvae drift for several months towards European coasts, where they enter into streams and rivers. There, they eat worms and small fish, as to build energy reserves for as long as 20 years before their last trip. This last trip will bring them back to their birthplace, in the middle of the ocean, a 6,000-kilometre journey without food, with one single goal: to reproduce before dying. For hundreds of years, eels have been important for the European culture and gastronomy, and have constituted a source of livelihood for many fishermen throughout Europe. Stocks seemed inexhaustible, until their population dropped suddenly in the 80s, with a loss of nearly 99% of the initial population. This rapid disappearance remains a mystery. Many studies have tried to understand the origin of this fall that could ultimately lead to the complete disappearance of the species. Is it a change in ocean currents that has disrupted their migration? Is it the presence of barriers to migration, such as dams, that prevent eels going up and down rivers? Or are they affected by pollutants that accumulate? To date, none of these explanations could really explain the timing and the speed of this rapid decline. Recently, we discovered high aluminium concentrations in eels collected in Belgium, a very surprising contamination which led us to think of a new hypothesis. Aluminium is a very abundant metal in the Earth's crust. However, not in streams and rivers where its concentrations are usually very low. Only when soil acidity increases can aluminium be released from soil and flow into rivers. This is actually what happened massively decades ago, when the rains have become acidic due to air pollution. This phenomenon, called acid rain, washed out soil aluminium into rivers. Once in water, aluminium has the ability to attach to fish gills. These organs are important for breathing, but also for regulating the fish body concentration of water and salts. These are thus particularly important in eels, which must adapt to both fresh and seawater. We therefore believe that aluminium could kill eels attempting to return to the ocean. To prove this, we would need to return to the past and assay aluminium in eels living there during the last century. It may at first seem completely impossible, but we think there might be one way to do this. How? Well, fish have a peculiarity in their inner ears. They contain small clusters of limestone called otoliths. These otoliths, which are important for the fish balance, grow continuously up to 3 mm diameter, forming new circles of minerals every year, similarly to the rings found in trees. During their growth, metals present in fish tissue are trapped within the limestone. Thanks to very sophisticated analytical techniques using a laser, these trapped metals can be quantified, giving us information on the abundance of metals in the fish tissues. Luckily, Dutch researchers have collected otoliths of eels caught in an estuary for many decades. With them, and in collaboration with teams from Belgium, France and Norway, we will analyse the eel otoliths collected over the last half-century. Thus, we can determine whether there has been a growth in aluminium concentration in accordance with the decrease of the eel stock. If our hypothesis is true, perhaps we will then have a means to facilitate the restoration of eel populations. Support our project. With your donation, even small, we could finance the analysis of the otoliths. The more otoliths we can analyse, the better will be the idea of what occurred to them. And this could give us the means of action for helping the recovery of eel stocks. Please support our project.